Okay, here we are on problem 4. Let me read it to you. If a volume of nitrous oxide at 45 degrees centigrade decreases from 50 milliliters to 25 milliliters, what is the final Celsius temperature? Assume the pressure is constant. Okay, now let's go through the approach. First thing is, we know this is a combined gas law problem because we have two volumes, two temperatures, and even though the pressures are constant, it's two pressures. So immediately we look at this problem. Now we want to take our data and organize it. Okay? So the first thing we look at is, we know because the pressure is constant, P1 equals P2. Second thing, we know at 45 degrees we have T1, but it's at centigrade, so we got to convert it to Kelvin. How do we do that? We add 273, which gives us 318. Also notice it's 45 decreases from, so that means this and this are tied together, which means V1 is 50 milliliters. Now let's go to the rest of the equation. We know that V2 is 25, so we just follow that and that comes over here. T2 is what we're looking for, so that's a question mark. Now again, because pressure is constant, we can eliminate pressure from this equation and rewrite it to be this one, which is V1 over T1 equals V2 over T2. Now we rearrange the equation. And again, we have the handout to review if you want to figure out how we do it. We now have T2 here. We have V2, T1, and we have V1. Now let's go back and plug the numbers in. V2 is 25. T1 is 318, V1 is 50. So putting in the equation, we solve it and we get 159 degrees, but it's Kelvin. The question is Celsius, so we have to do another conversion. We know that TK is equal to TC plus 273. TK is 159, TC is what we're looking for, and 273 is the constant. We rearrange the equation and we get that TC is minus 114 degrees Celsius, and that is the answer.